So Edwin, if you can start sharing your screen, and I'll...
Yes. Good morning. Just a second. Is it visible or? Can you hear me and can you see the presentation?
Yes, we see the presentation and we can hear you. Okay. Can you turn on your camera, because that's sort of always nicer, but I don't know if I blocked you from it.
Yes, I tried to, and then it said it. I tried again.
Ah.
No, I cannot start your video because your host has stopped it.
Yeah, I tried to unblock that, but no. Okay, just well,
Yeah,
while you're working, while you're present.
Yeah, well, you don't miss a lot, but okay. Well, thank you very much for inviting me to present our project, Fully Documented Fisheries. It's an ongoing project, started 2 years ago. We still have 2 more years to go, and probably a longer extension. So what you're going to show you are some preliminary results, and but we'll give you anyway a good picture of what is going on, where we are, and where we're heading with this research. Irene, yeah, it's working. Well, first I will tell you something about the background of electronic monitoring in the Netherlands. Now we come just to decide why we should implement a project like this. I explained something about the electronic monitoring part in this project, more the classical form of it. Then I will tell you something about the computer vision technology, image recognition we developed in the project, and how we're going to use it and how we are using it. I make a short comparison between human and computer, so like the classical EM and the computer vision technology. And I give you a short outlook of where we're heading in the future years. Well, first of all, the aim of the project is to improve data collection and catch registration in fisheries. And actually the problem is already half solved, because all the landed part of the catch of commercial fisheries is well documented. It's sorted by species in nice boxes. You can collect the information at the auction, it's registered, we can download it, we can work with it. The problem is at the part of the catch that it's not coming to land or discarded. And this is difficult to monitor because it's at sea. We can be there always. We have to go at sea to collect information. It's very time consuming and labor intensive. The reason why our ministry is supporting a project like this is because of the landing obligation and the need to record the discarded part of the catch. So this is a regulation within the EU, but it also could support research to improve selectivity and survivability of discards at sea. Well, this is how we normally would collect discard information. I've already told you, we have to go at sea. It's labor intensive, it's hard work, and it's working well when you're on board. Species identification is very accurate, but as I said, it's very labor intensive, which results in a very low sampling coverage. So when you are on board, you cannot sample the complete catch. You have to take subsamples, which comes down to less than 5% of the total catch. So you actually can have in your hands and collect information from. And for the total fleet is even less. Currently, there are hundreds of vessels at sea at the moment, and we only can be at 1 or 2 trips at the same time at sea, which results in a very low sampling coverage on the fleet level. To tackle that, we introduced electronic monitoring already a couple of years ago. I came from Canada. We use standard systems, and we run some projects and programs with it. It has typically a computer on board, digital camera, sensor information to be able to analyze the catch later on in the software package provided with the systems. So we did a project on cod. In the beginning, we were very skeptical. I thought it was never going to work, but it proved wrong. We were very well able to detect cod in the fisheries with larger match sizes. The fisheries really directed on cod. We had a very good result. It was a bit less in a mixed fishery. On the left panel, you see that where there was a lot of catch of other species and got lots of bycatch project. But still, so far, we are very positive and started to continue using electronic monitoring systems on board of our vessels. And we took on some more challenging projects like monitoring smaller species. As you see here, we tried to collect information on discards of sole, which was indeed challenging and more difficult, but only with slight protocols we were able to get some very good results and very accurate measurements of total sole catch and discards on the beam trawl fleet of the Netherlands. But now to the fully documented fisheries project. What we wanted to do different in this project is that we didn't want to use EM as a check on logbooks. Like in the previous project, we asked the fishermen to register cod, to register sole, and then with the EM information, we collected if the logbooks were filled out right. So we validated, we checked the logbooks. But in this project, we want to use video footage, EM, to get an estimation of the total catch directly. So no involvement of fishermen, no involvement of logbooks. It's just analyzing the footage and then estimate the total catch. And to do that, we split up the project in two parts. It's a saying here, we are betting on two horses. I think it's a Dutch expression. I directly translated in English. I think for English speakers, natives, it doesn't make any sense. I think the correct phrase is hedging your bets, but what we wanted to split up, we wanted to go two paths. So we want to do that because the challenge is in the big volume of data we have to analyze. So we started to use classic electronic monitoring and invent some methodologies how to do that. So we have to go for a more subsampling set of footage and then raise that to trip level, fleet level to make some total estimates of the catch. And on the other side, we tried to introduce computer vision technology to do actually a census of analyzing the complete footage. We did this because we were not sure if one or the other should work. Particularly the computer vision part was very new, and there were questions in the beginning of how far we could get with this technology. So this is why we chose for this setup. In the meantime, turned out we can also learn from both parts. We learn from the electronic monitoring part as we learn from the computer vision technology, and we can use the knowledge and expertise we developed in both areas. So first I would explain the electronic monitoring part, the classic stuff. So we stream data from a server, like all EM projects. We can replay the video, we can fast forward, we can stop it, we can zoom in, we can zoom out. So we all do this for the manual review. We select some random footage because there's too much footage to review all of it. And then we try to extrapolate the selection of the reviewed footage to hole and trip level. We investigated some different techniques to do this, and the first one is we took snapshots. So these are still images from the footage. We randomly selected snapshots, and then we analyzed what was on the video and extrapolate that to the total catch of a hole. And we used as a variable extrapolation factor, we used total catch for that. In this particular case, we used total landings of plays, which is a commonly called species. And then in that case, we could extrapolate the data we have from the discarded part of the catch to the whole fleet or to the whole trip level. However, the results from the snapshots didn't really work out that well. What you see here are the results from 6 vessels, and you see it goes all over the place. So on the y-axis, you see the absolute number of deviation from the ground truth compared to what we saw on EM. So for vessel 1, we have an underestimation. For vessel 2, we have an overestimation. And for vessel 3, again, an overestimation. Vessel 4, a significant underestimation. Vessel 5, same. And for vessel 6, we also have some extreme outliers. So it turned out that our method does not really work well. Also pay some attention to the values on the y-axis. They are enormous. So we thought this is not going to work for us. So we had to go back to the drawing table, come up with some new ideas, and we started to move from still images to moving images. So we start selecting some video segments and then analyze the data and then try to extrapolate that again. We figured out that if we go for 5 1-minute selection from a complete whole, we got the best result. In terms of the practicality, it's not too much time to review 5 minutes, and for more accurate results to extrapolate it to whole level. The extrapolation factor we use here is not catch, but we use total sorting time, which proved to be a bit more accurate. And the results here, you see some preliminary results for 2 vessels, and you see a huge improvement for vessel 1. Actually, we are spot on. Also pay some attention to the difference in absolute numbers and weights for the catch. The scale is completely different than from the snapshot, so we're within a limit of 20 or maybe 10 kilograms difference, which is acceptable. For vessel 2, it's less, but still acceptable, and we have a slight bias and an underestimation. And we see this also a bit for the other vessels, but it's within acceptable limits, we have to say. So we are quite happy with that result so far. And then the other part, so the computer vision part. What we did here is the most work here is data acquisition, as we call it. So we have to collect pictures, footage, and then start annotating, pointing out on the image where the exact species or fish are you want the computer to see for you. And as soon as we have enough data for that, we can train an algorithm in learning what it needs to see. In this example, for example, place or undersized place. And when we trained it, we're going to test if how correct the algorithm will be in the validation process. And in the end, it's the idea that the algorithm will review a complete set of footage of a whole trip or a whole year. So there is no random selection and extrapolation. It's just like a census analysis of all data. So as I said, this is how it looks like. So we collect footage, we annotate it. You see that in the right box is an annotation. This is a place, and the computer starts learning how a place looks and how we can recognize it. So we started easy. For example, here we did a sample with rays, with the brown side up, the dorsal side up, which is very recognizable. We turned the ray around to be a bit more challenging already to see differences. We put some extra other elements in the picture, and then we try to mimic more the reality on board of a fishing vessel. And the algorithm was better than we expected. So it was really able to recognize fish. For example, in the top down right picture, the algorithm still recognizes the ray we want him to recognize. And in the end, we are now in this situation where we can actually analyze moving images. We can detect different species in different positions, also when it's covered, also when there's occlusion with the fish, or benthic species, other stuff is over the fish. And it's also important we are able to track the same fish through the image, which is important for double counting stuff. Here the results we have so far in the algorithm in our first phase, so the first training, first validation, and then we did some trials. This confusion matrix, you have the ground truth of fish species on the y-axis. On the x-axis you see what the computer predicts, and in the diagonal line you see that there is a good results so far. The misses are more in not seeing the fish, so it's background. So it's supposed to be there a white thing, but he's missing it. He's seeing it as background. But if it sees a fish, it's the species recognition is very accurate. So the first results are very good. And then we also try to compare it to a human review. So what we did is we had 2 EM reviewers going in competition with the algorithm, the computer. They saw the same footage, and you see the here that we did it in counts. The ground truth is on the x-axis this time, and the counts of the observers or the video reviewers and the computers are on the y-axis. The black line is the truth. So you see a slight underestimation of the EM reviewers, as we saw before, which is what we expected, and then we see a slight overestimation of the computer, and this has to do with the double counting. As I said, it's difficulty in tracking fish through the footage. We improve that now, but it results a bit in double countings and in an overestimation. But the important thing what we want to point out here is that the difference of the EM reviewer is less than the computer vision technology, but still they're both not far off. So this was actually a promising results. And yeah, just to give the clue away, we decided to go more on the path of the computer vision technology. Still there are things want to improve, but we think we can manage in the next 2 years. And we just see the advantages over the manual EM review, and this is because it's faster. So you get the whole senses of information. You not get the bias and the variability you introduce yourself by extrapolating, subsampling to total catch levels on a trip level or a whole level or even fleet level. So the idea of analyzing all the footage is appealing to us. And we don't need the large infrastructure we now currently need for the EM review. We have to download the video from the vessel. We have to store it somewhere, we review it, so we have to keep it somewhere, and after review we can destroy it. When we do a computer vision analysis on board, we can do that directly at the vessel itself, and then after that we can even destroy the images, and we just get the output from the algorithm, just the number or weights of fish per species. And another important thing is there is no doubt when you review footage, you're not always very sure on what species it is, if you are correct, and a human being has to make a decision. This is species A or species B, and the nice thing about the algorithm, it can estimate its uncertainty. So I'm 85% sure this is a place, and if it's not, then I'm 50% sure this is a sole. So this is an extra advantage of using an algorithm in the analysis of the footage. And then, the outlook piece. So if we manage to create a system like that, we think it can increase transparency and traceability for the fish themselves. It's just like a computer is counting. There is no human involvement there. There's no third parties. It's just like a system that counts fish. And another example of an advantage here is you could also move to a more like compliance by design. So if you have algorithms and systems on board that automatically analyze the catch, it's also something you could check, something we picked up from the financial industry, but also like the food processing industry on pork meat. So the control is more on the software, and it's checking if the software is doing what it's supposed to do, which makes it way more efficient, and go on the workflow and actually take samples and check if everybody's doing the right stuff. And in the end, is also like we think if we're going along this path, is that the fisher is really becoming an agent of the data collection process. So it's not a camera on board. The footage is collected by someone and reviewed by someone else. It's just like the computer is scanning it straight away on board. So you get more like an ownership of your own data for the fisherman, and then he can it's like an idea is more part of its data collection process. I think this is it. I don't know, Irene, if the opportunity for questions are now or after.
Oh, we have like a short time for questions, so if people want to put them in the chat. I think I have unlocked your video, so you can turn on your video now, I hope.
Okay.
Yes, there you are. Hi, Edwin.
Yeah. Hi.
So nice to see you. So sorry about that.
Stop sharing, or what do you want?
We can leave yeah, okay. You can stop sharing now. That's a good idea. So we have a first question is, how long does it take to teach the algorithm to recognize species? How long?
That very much depends on the complexity of the situation. So in a demersal fisheries, like in a bottom troll fisheries, you can imagine you have a very mixed catch with all kind of stuff on the sorting belt. and then you need a lot of images to train the algorithm. If you just have one fish on a blue background, for example, you don't need that many images anymore. The algorithm picks it up easier. So the complexity of the situation also makes the training more challenging. You need more info to get the result.
Okay. And there was a follow-up question. Doesn't it get confused between species? But that's again, I guess, more training and more image recognition to teach the computer, basically.
The more training data you have, and the more accurate it is with the reality, it's getting better. But I have to say that the computer is in some situations better than a human being. For example, the rays I showed you, when the ventral side is up, the white side up, our ray experts couldn't really recognize the ray species from the video. And a computer doesn't really have any issues with that. It doesn't really matter if the brown side is up or the white side is up. We don't know what it looks at, but it looks at some different features. You can imagine that a computer can very easily and accurately measure stuff, for example, like ratios between heads and tails and wings and stuff like that. So it's probably using this kind of features compared to a human being, and in this case, getting more accurate. And the other part is if you're human, an algorithm can touch a fish, like the difference between some species you can feel like it's more, it is slippy or raw. This kind of information, it's of course impossible for a computer to recognize, but it uses different ways of recognizing stuff.
That's fascinating. So, and I was thinking, because I don't see other questions. So this technique really works well when you have like a trawler with a conveyor belt. But I know some colleagues of you also are thinking about using these things inside nets or something for the pelagic fisheries, where you actually do not have a convenient conveyor belt things. So what I was thinking, where are the next steps in this?
Yeah, there are also projects going on indeed for analyzing footage in the water. It's also possible. It's the same principle. It's just as soon as you can see the fish, have a clear shot on the fish, you can train an algorithm. So there is different ways to go with that. In this particular case, we continue to go on board because it's a registration of catch and not of what's in the net. Mm-hmm. So, but both situations are options. Yeah.
So another question: how expensive is this?
The biggest chunk of the cost go in people annotating the images. So in the beginning, this is a lot of work. It takes time, and time is money. So this is where the most of the expenses are. As soon as you have a good training set, you can train algorithms, and you can pick algorithms from the nets. They're very standard. We don't use very complicated situations. So as soon as you have the training sets, then it's not very expensive anymore. And the equipment on board, of course, you need a computer to collect the footage, to prepare the footage, and then analyze the footage. Those computers are expensive, but it's a one-time investment. In the end, you would see that it's going to be cheaper than getting people on board or label, of course, but you don't have any more in the end.
So it's basically the startup cost is high, but then it's sort of.
Yeah, but I can also imagine, say, if there's going to be a point that we start sharing data between research institutes and researchers. For example, ISIS is facilitating a situation like that where you have a database of images and you can make use of. You will also have a massive cost reduction there in development algorithms.
And last question, so this is not happening real time, right? You analyze it afterwards.
Yeah, our aim is to get it within 2 years now, almost real time. So what happens, there is a camera on the deck, there's a computer there who prepares the footage. We use a very narrow picture, and we stick a line scan, and we make a very long picture. That picture is going to send to a computer to the bridge of the vessel, because it's a better, drier environment, and we need a bit of a heavier computer there. And then it can immediately analyze the footage and provide an output. So we think that between two holes, we are able to analyze all the footage. So it's almost real time.
Okay, cool. Thank you. Well, we don't have time for more questions. I see some more, but maybe later on. I would like to pass the floor to Luca. Yeah, there you are. To Luca, hi. Nice to see you. And again, sorry for introducing you as the wrong person, but glad that we have the video working, which is really good. And yeah, if you can start sharing your screen and your presentation.
Yes.
Learn more about what Global Fishing Watch is up to.
Thank you very much. So yes, first of all, do you see my screen? Can you hear me all right?
Yeah, yes. All good.
Yeah, okay, cool. So first of all, my name is Luca Marsaglia. I'm a fisheries analyst for Europe at Global Fishing Watch. Thank you so much for having me here today. It's a pleasure. I actually graduated from Wageningen University, so it was really nice to see Edwin's presentation. The slides took me back to some of the lectures we had. Anyway, I hope I'll be able to provide you with some insights on advancing in digital fisheries monitoring, and particularly in the context of global perspectives on transparency in fisheries. So I will first introduce a bit Global Fishing Watch and our work at Global Fishing Watch, and then I will jump on a little demo of our main product, like our main tool, that is the Global Fishing Watch map. So Global Fishing Watch is an international NGO that uses satellite technology, machine learning, and data visualization to build an accurate picture of human activity at sea. And all of this is done through free and open data and tools. The main goal of Global Fishing Watch is to support greater transparency, novel scientific research, to promote sustainable use of our ocean, as well as the reduction of IUU fishing. Some of the characteristics of our tools and what have been driving the development and the creation of our tools and of our data is that our data are historic, so they date back for several years across all of our data set. And our data set, we'll see it in a moment, but include fishing effort, encounters between vessels, nightlight vessel detections, radar detection, vessel events, and vessel identity. Our data are near real time. We have a 72-hour delay, so 3 days. They're relatively easy to use for both experts and non-experts. And last but not least, they are accessible, like online and free. And I will show you also later how you can access and download some of our data. So some of our data set include, of course, fishing effort coming from IES, which is the main source at the moment, as well as VMS. We have 10 countries that have shared VMS with us. We'll see this in a moment too. And we have daily fishing effort that, again, is searchable and downloadable. And also you can filter it by gear type, by flag state, and all of it down to a resolution of 1 kilometer. We have vessel present data. This includes, for example, night light detections and radar detections of vessels, as well as vessel activity, like port events of vessel, encounter between vessels, and we match also the presence data. So for example, night light detections, radar detection, we match it with IES. We have transshipment data. So again, when two vessels are encountering at sea, we have a pinpoint identifying the encounter, and we also can collate the fishing authorization as well as identifying ports that are frequently visited by this vessel. Something that has been developed in the last year is also to include some oceanographic data in some of our tools. And so, for example, sea surface temperature, salinity have been included, but also now we have the option within our tool to add your own environmental data. And we'll see this when I go into the demo. So since Global Fishing Watch start, let's say the main source of data has been IES, which I guess most of you are comfortable with. It's automatic identification system. Is a device that was created for safety at sea to avoid collision between vessels. And we try to combine other satellite data to reveal more activity at sea. So a lot of our work lately has included working with Sentinel-1, European Space Mission, and Sentinel-2. Those are Sentinel-1 SAR imagery, so radar data, from which we get vessel detection, and Sentinel-2 is optical imagery, from which we do the same, as well as with VIRS imagery, so nighttime optical imagery, where we pick up the presence of fishing vessel using the lights that they use to conduct fishing operations at night. So Global Fishing Watch in the last years have been partnering with governments that are committed to fisheries transparency and that are willing to share their data by our map, particularly VMS data. And we believe that transparency is the cornerstone in the fight against IUU and also on the achievement of responsible ocean stewardship. Since 2017, we had 10 countries going transparent with us, so sharing VMS with us and make it public on our tool. And we believe that as more countries commit to publish their vessel tracking data, MCS, so monitoring, control, and surveillance activities, are supported. And so this culture of compliance is created. And we hope that fishing nations can keep this momentum by enhancing fisheries transparency. A big part of our work includes research. We collaborate with leading scientists, research institutions, universities to develop data sets and models to create new insights into human activity at sea. We've published over 30 peer-reviewed papers. And I have here an example of one of the latest study that was published, which was a collaboration with the University of California, Santa Barbara, to investigate whether vessels that were known to have used forced labor on board behaved in a statistically similar way to one another. So the team built a training data set from information of reported cases like media reports, NGO investigation, public persecution cases of reported forced labor. And then this was used as the training data. And the model identified similarities across five behaviors. So those 5 top predictors that you see there on the right. And so where those behaviors are similar across the vessel, then there is a high risk of forced labor that is predicted. And currently, like, we're working to expand this work from a model to the tool, but of course we need more training data. So actually, if you have no known data of forced labor, please get in touch. And we hope that this will help authorities and industry groups to implement policies addressing forced labor at sea. Another part of our work is analysis and training. So we have a globally distributed team of analysts. They aim to provide insights and training to help authorities to use and benefit from our data and our technology. And there are some key areas that usually our data are used from governments, which is IUU fishing risk assessment, transshipment monitoring, port control implementation, marine protected area monitoring, and MCS operational support. So this was a bit it about Global Fishing Watch and our work. Now I will give you a little demo of our main tool, that is the map. Global Fishing Watch map is accessible from the Global Fishing Watch website, globalfishingwatch.org. You see here on map and data, you have the different portal, the different tools. Today we're focusing on the map, so I'll click on our map. We go to the map. And something that I recommend doing is to sign in It's free and it takes 2 minutes. In this case, of course, I'm already registered. So like your initials will pop up there, and this will just give you access to all of the functionalities of the map. So this now should load. I'll refresh this. Here we go. So just for the context, I guess I will go into an area that you're confident with, which is Baltic Sea here. So I'll start to introduce the main parts of the screen when you're looking at the map. So you have the central map, where now you see special apparent fishing effort represented in grid, and we see that as we zoom in, the resolution of it changes. And this is gridded fishing effort coming from IES. We also have different sources of apparent fishing effort data, like BMS in this case, that we don't have for this area for Europe. So I'm just gonna remove it to have less things there. So at the bottom of the screen, you see this time bar. Here you can select your time range. As I mentioned before, the data go back for several years, and you can change time either by using the bar like I'm doing now, where I'm going back all the way to 2019, for example, and the data will load accordingly. You can also use, there is a calendar icon there where you can input your specific date, and you can change. Then what we see here again, where we see more, of course, close to blue is where we have less hours of fishing, apparent fishing. Where we have white is where we have more hours of fishing. On the left panel, here is where the things that you see on the main map is where you load them. We have fishing, so coming from IES, that you can filter here for, again, in this case, VMS of other countries that, as I mentioned, we don't have for this area. You can filter for different flags of your interest, and you can filter for different gear of interest as well. So something else you can look at is presence. So with presence, it's meant that it's the IES of all vessels and not of all fishing vessels. So clearly you see like here now some of the main shipping lanes coming in. And also a layer that you can add is night light detections. So detections coming from virs. I need to turn off the other layer, otherwise it will be messy. But yeah, this is just vessel presence that was identified by using lights of the vessels, which started to load now. And again, you can see vessel presence with night light detections. I'll go back to fishing and possibly give a more like clear cases, like use case for this area. We have some reference layers that you can load. Here we have the FAO major fishing areas. So here we have the 27.3, if I'm not mistaken. And I want to show you how you can interact with the data. So something worth mentioning is that you can add your own reference layer. And so everything that I'm about to do, you can do it for your polygon of interest that you can upload as a GeoJSON or as a compressed shapefile. But yeah, you can find out about more supported formats there. And you can also include point data. But what you can do, it's you can go on the layer, and then you can run an experimental analysis, for example, for this area. And here, whatever is loaded on your left, in this case, we had apparent fishing effort from IES and not filtered for any gear, so for all gears since 2019 to 2022. And you can see how that changes. You can look at this also interactively. Let's say I select 1 month of 2019, or let's do even 4 months. From January to April, we see the data change accordingly, and as well here the evolution of parent fishing effort. And you can also see how now I played there, and you see the parent fishing effort again changing accordingly, as well as the evolution on the bar graph there. So there is new tools coming up to use. So not just looking at the evolution of a parent fishing effort, but there will be more in-depth analysis that now you can do by yourself, because you can click again on this layer and you can download the data as a CSV, GeoTIFF. You can group the data for what you want. So vessel, flag, gear type, or flag and gear type. You can choose your temporal resolution and your spatial resolution, and you can download the data and work with it. Something else worth mentioning, when if we zoom a bit more, and let's say we click on the grid there, you will see all the vessels that were responsible for the fishing effort in that particular area, and you can pin the track of that vessel. Remember that is always dependent on the time that you've selected. So right now we're looking at from September 2019, 22nd of September 2019 to January 18, 2020, and those are the tracks of the vessel. I'll turn off the apparent fishing effort so it's a bit clearer. And we see where our algorithm has identified the fishing. That is where you see the points. Those are fishing events, and you should see it a bit more bold. Actually, those are some of the latest changes. Before it used to be white where the fishing was identified. And then you have here in light blue the port visits of the vessel. And again, as you change the time, you can the vessel track again will adjust accordingly, and on the screen. So this it's a way to load a vessel track, but something else that you can do is search for a particular vessel by typing the MMSI or the IMO or the name of the vessel and look for a specific vessel. We have environmental data that you can upload your own environmental data as polygon or as tracks. For example, if you have marine mammals data, shark data, you can upload them as tracks. And this is it. I think I've shown some of the main functionalities, and I might be running out of time. So I'll close here. Something that just worth mentioning. Let's say you have done your work, you have loaded some layers, you have uploaded your own data set. You can click here on Save the Current Workspace, and you can rename it. And then you can copy the link and you can share it with anyone. At the moment, those workspaces are public, so anyone that you share that link with will have access to that. And then if you click on your initial, you will have your workspace saved that you can access back again. So you see Webinar FishSec, then I can click on it and I will go back for where I left my work. And this is also a very easy way to share it with other people. Please use the feedback button. It's really useful for us to improve the tools and the data. And also, if there are any bugs, you might be the first one to report it. So it's always useful. I am done. Thank you very much. It's again, it's a pleasure to be here. And we just started our work in Europe, really in the Mediterranean the past few years. So really open for collaborations, and yeah, so thank you very much. I don't hear you.
It helps if I unmute myself. Sorry. Thank you so much. Really interesting. Great to see. I've been following Global FishSec for a while. And it's great to see also that it's now active in Europe. So there are some questions. First of all, somebody asked, is it possible to get data from Global Fishing Watch that are not so gridded? So what's the, can you zoom in more, so sort of to a higher detail level?
Yeah, so I will assume that when we're mentioning this not gridded, we're talking about tracks data, so the ability to download the vessel tracks. It's something that might happen soon. We have some issues of confidentiality on sharing all tracks data, and also you can imagine it's quite heavy data. Like a vessel track data is many IES points, so it's quite heavy to work on the tools. But we'll get there, I think. But right now you can download to 0.01 grids, which is quite it's quite good resolution to work with, I'd say.
Good, thank you. And another question was, are there any talks of the EU eventually sharing their VMS data for their vessels? How far along are you in talking to member states?
EU countries, we are. It's of course our goal. It's been again a little like less than over 2 years that I started working Global Fishing Watch, and it's pretty much when Global Fishing Watch works in Europe started. We're starting to have like conversations and starting to do engagement, especially in the Mediterranean. So with GFCM, and we'll see. We know it's a long path to get VMS shared in Europe because of all the privacy policies behind it, but we'll see. We'll see. We're hopeful, and yeah.
Yeah. So how is it with, because are there data protection issues?
Well, with the work we do, I mean, all of the data our data are publicly available and downloadable. So no, like right now, the confidentiality issues that we have is in sharing vessel tracks of non-fishing vessels, for which again we have an agreement with the two main satellite providers, data providers to us, that are Spire and Orpcom, that which we can share tracks of non-fishing vessels, and that's why in the map, like when I showed the like just the presence, so the non-fishing vessels, you won't be able to look at the tracks like I did for the fishing vessel, and then same like downloading the vessel track, also that is somehow a confidentiality issue, but that hopefully will be solved soon. Again, our main work involves transparency, so that's what we push for.
Great. And just a question, small scale vessels, or smaller vessels that do not have a VMS or AIS, do you have projects for those as well?
Yes, so there is a whole small scale fishery work that is being developed, and especially is developing in Indonesia with other tracking devices, and they're experimenting other tracking devices. But I'd say that it is very promising what we're doing with radar detections and SAR imagery, for which that we're seeing that over, like, we can go down to like 12 meters. We have good chances of identifying a vessel from the SAR imagery, and we're working on also algorithm to identify likely fishing vessel from radar detection. So lots of interesting work to do on that, especially because as you know, like there are a lot of countries that do not necessarily use IES. Like Europe is a very good test case because most of vessels do have IES. Especially, I'll say, like in your area, like the Northern Atlantic and Northern Europe, it's really good data. But yeah, for sure, it's something, for example, in the Mediterranean that we know we need to work with. I see another question on how is that converting into vessel tracks. Actually, we won't have vessel tracks from SAR or optical imagery, of course, because it's just the detection of the vessel. What we can see often is the course of the vessel, so where the vessel was going. We can try to estimate the speed, the length of the vessel, but of course, we don't have vessel tracks, so it will be a different type of analysis or way to look at it, to interpret the data and to try to quantify fishing. But yeah, it won't be through tracks, of course, because it's just an image, right?
So, and then a final question. I have somebody who might want to cooperate with you because they are testing an AAS for small-scale fisheries in the Adriatic Sea. And would any AAS be able to integrate it into the global fishing watch system, basically?
Likely if the IAS it already is.
Okay.
I mean, we pick up IAS signals. So if they are using IAS, then and they are likely in our data already if they are already active. And it'll be interesting to get in touch with these people, and because again, might be an easy way for them also to look at the data, because if they're using IAS, it should be there. I don't see why it wouldn't be there. Yeah.
Thank you. Okay, then I think there are some more questions. We'll look at them later, but I wanted to give the floor now to Kristian Schreiber for a presentation on what Denmark is planning for their vessel monitoring. You should be able to share your screen now. Yes.
I hope so. I am. Thank you. Oh, I'll just need to move this so that we can actually see it. Otherwise, it's not worth that much. There we go. Not. All right. Well, I see you're seeing all of my screen. Perhaps if I can share it a bit differently. There we go.
No, it was better just now. Now we see your whole PowerPoint.
Yeah, exactly.
And just now, but you did before. Yeah, now it's okay.
All right. Well, thank you for having me. My name is Kristian Plet-Hansen, and I'm the camera coordinator at the electronic monitoring project. We are operating in Denmark and the Kattegat Nefrops fishery, but also for the new projects that are coming, at least in the future here. But we'll come more into that later in the presentation here. So are you seeing my screen exactly as I see it? Because I think you're missing some parts of the slides then.
I see to the left, just the blue bullet points.
Yeah, all right.
If there's anything to the left of that, then I wouldn't see it.
No, there's not. It's just the top where I see some new share and all that. So here on the first slide, I just want to give a brief introduction to the installation process. And it's just that I can see the top part is being blocked by the sharing screen that I have on my computer. So if you're not seeing that, then it's not a problem. Anyways, then so this project we're running in the Kattegat, it began in December 2020 in terms of installation. We had on the first vessels here. It's 12 vessels in total that were to be fitted with electronic monitoring with cameras. And we started in December 2020. It took a bit longer with this than anticipated with this installation phase. But installation was finished on all 12 vessels in April 2021. And as a rule of thumb, we've used 1 day for drafting the vessel monitoring plan, or VMP, for each vessel. And then based on that, then the installation can take place. That has taken 3 full days for all but 1 vessel. I know that Edwin was also a bit in on this, but anyways, we use the Black Box VX camera system by Anchorlab, but there are other operators in the market. And this is just to get a sense of what the overall system consists of. So we have rotation sensors, and we use those to register the fishing activities, but you can also use hydraulic sensors, and that depends on the vessel, what is the best suitable. Then we have a GPS antenna, which locks the position at a 10-second interval, and GSM antenna to transmit the data. We use online transmission. There are also the option of doing manual swapping of hard drives. Of course, depend on the options you have for online transmission. But in our case, that is the optimal to do online. Then there's a control box, which is basically just a computer on board inside the wheelhouse. that stores all the features and is connected to a screen. So our vessel owners, fishers, they can actually see what is being recorded on their vessel. And then, of course, there's also the cameras to film the catch and sorting, and they can be placed several places around the vessel. In the 12 vessels we have in the currently, we have 4 to 6 cameras on the vessels. So there's only 2 which have 6. Most of them have 4. And the way the data flow works then is that we get sensor data in from each vessel. We do that every day. That is transmitted on the mobile network, and then we can also order video data there. The sensor data goes via our REM system provider, which has the benefit of making it more flexible if we need some sort of support, if there are technical difficulties. And then it goes to our IT service and our data storage, whereas our video data, which we do not get transmitted automatically, but actually order, gets transmitted straight away into the agency's data storage. And then we do the analysis based on all these data. Just to give a brief overview. What it actually works like is that we have the sensor data on a vessel. So this is actually the software we use, the analyzer software, and we have human audit going through. We do not have currently developed an AI program, although we are very interested in doing that as well. So in terms of the sensor data, the way we use that is that what you see in the map here is the top part of it above the map of Denmark and the Kattegat area. We have different lines. So we have a blue, we have some purple, we have some yellow and some orange, crisscross and tips and tops in the top bar. That's all data input from the sensors. So the blue one is the speed in knots, but we also have the purple, for instance, which is a motion detection in the actual cameras. So it detects whether or not something is going on within the field of view of the camera. It doesn't matter if it's a seagull flying in or it's a human being moving in to sort the fish. It just shows you that something is going on here. And then at the same time, we also have a bit further down below, there are 2 green bars. There's 2 of them. And it's a bit difficult to see, but what we have here is the rotation sensor input. So this is where, the 2 green bars, where we have the actual trawls going on. And we basically have the full trip in the top part. And then we have all the video that has been recorded. That's the gray bar as the bottom part of the sensor input. And when it's gray, it means that we have not ordered anything at all, but it's recorded from the trip. Yes, and as I said, we have these different sensor inputs. It's a bit more easy to see here, where we have these arrows showing the rotation sensors when the trawl is going in or out. It's a bit difficult to see, but they're there. So based on that, then we can infer where we have the hauls taking place. In this case, on this trip, we have 2 hauls. And then after the hauls, that's where we have the actual catch handling. And we can then use the motion detection to get a good sense of where are we expecting the actual catch handling to take place. Because we're not interested in looking through the video of the actual haul. We are interested in looking through the video of the catch handling afterwards. So when we have this in our sensor, then we will order the video, and we go in, and basically you need to go in and order that manually. And then when it's ready, then we have that the previously gray bar turns green instead, and that means that the video chunks are now ready for audit. When we have it like this, then it's ready for our video auditors to go in and then make a note on where the actual catch handling took place from when it started and then to when it ended, and do the actual video audit where they manually, as the classical term Edwin used, go in and actually view the video. And it will look something a bit like this. So here we have an example of from a vessel in our evaluation report. The images are from there. In this case, it has 4 cameras. And what you might also notice is that some additional blurring has been necessary. We have these in the left-hand side with these 4 different pictures. We have some black areas. That is a masking we put in to limit the video of areas where humans are and focus on where the actual catch handling takes place. That being said, then it's not possible to fully make certain that we do not detect or film any humans. And when that is the case, then we need to put in additional blurring, as is the case in these 2 pictures shown here in 3B and 4B, they are named. The masking, so the black areas, that cannot be removed from our side either. It can be adjusted prior to the trips, but after filming or video recording has taken place, then the masking is set. So we cannot go in and actually remove it afterwards when a video has been recorded from a trip. That's fixed. And you can see that in the wheelhouse as well on the screen where the masking is, so you know where you're at risk of being video recorded when you're on the actual catch sorting. So this is what our video auditors will go through. They will look through the video for the catch handling. And then based on that, then we get a picture of every single register they make. So the way it works is that they go in and they make a register of different species that are what we want to do audit for. And the human audit is there to do the species identification and then also make the length measurement. So we take a length measurement of every single register, and what we get out is a picture, as we've seen 2 examples on the right-hand side here. One is a cod, the other is a hake. And the length measurement and the species identification based on the human is also then in the actual image. But then what we get is that the computer makes well, it calculates the length based on the pixels in the video or field of view and makes that into centimeters. And then also do an ID marker, take a timestamp. We have a haul ID, which is unique. We make for every single haul, which is also then put on the catch handling. Then the start and stop time of the haul and position as well, actually, the trip ID, which is the logbook number. So that's linked to the electronic logbook. And then we also use a tag code, which is O and DT. DT is for double checks in Danish, whereas O is for original. And we do that because 10% of what we go through, we actually re-audit that again. And the reason for that is we want to make certain that we have a high enough quality in what our video auditors are seeing. So we have another video auditor re-auditing a video that has already been done by a previous video auditor. So we make a checkup basically to see if we get the same number of registers for the different species and also the same length measurements. And of course, you do not get exactly the same, but we get within a tolerance margin. We have a very good agreement between the different auditors, and the 3 times we've had disagreements where we've then had to do a follow-up, then we of course would go in for my side or my project officer and then double check this as well, and then have a talk together with our video auditors on where do we see the discrepancies. But at the moment they are getting very, very senior in this, have been doing this for more than a year. So we see very good agreement between them, but still continue to do this double check just to make me be certain. Then we also have a category code, and the category code is landing or discard. So the reason we do that is we both register landings and the discards of these species, both to be able to actually verify it in the landing declarations, but also because if we are to actually do, as we've heard about with the machine learning, then you need images, and then you might as well need images of the landings as well, because you need a lot of video material, image material to train your AI when you start to do that later on. So weight is not part of this, I might add. That is actually put on later by the length weight relationship for the species. So it's not actually in the raw data. If you just look at the 2021 results from this trial or project, then we've viewed 197 trips and 362 hauls and made 38,715 registrations, of which 29,000, a bit more, were whiting. So the vast majority were those. We have 6 focus species in 2021. So they're showed here in the image on the right-hand side. We have A is a cod, B for haddock, C is hake, D is saithe, E is spurdog, and F is whiting. So A, B, C, and D, they are all covered by the landing obligation with no exemption in this fleet segment, whereas spurdog is a protected species and has to be discarded, and whiting has a de minimis exemption. And quite luckily, we also see that the majority of registrations are the de minimis exemption. The vessels we've had fitted with the cameras, they've had an average of 88 trips in Kattegat in this year, in 2021, sorry, not last year. Where we had one vessel that actually had not been fishing in Kattegat, so we have not reviewed that. So in essence, we actually only looked at 11 vessels, whereas the highest number has been 130. And usually we've had between 1 to 8 hauls, and actually usually 2 hauls per trip. And the reason I mention this is that we do not just audit a certain share of the hauls, we audit a minimum of 10% of the trips. So if we have 6 hauls in a trip, then we go through all 6 hauls. If we have 1 haul, then we go through 1 haul. And the reason we do this is to make it's actually a bit easier to compare what has been entered in the logbook, but also what's in the landing declaration compared to what you see on the video audit if you do it on a trip-by-trip basis rather than a haul-by-haul basis. So in 2021, we actually were a bit overshot on the terms of what we needed to go through on the audit share. On average, we actually had a bit more than 18% share of audit, whereas the lowest was 15%. And the highest was 31.6% audit share. So we are above the minimum threshold of 10% for that year. One of the, I think, main interesting results we've seen is what's shown in this figure. So what this figure shows is we have on the x-axis, we have the time in months. So if you go to the left-hand side, we're in March, then April, May, June, July, August, and September. And then on the y-axis, we have the number of fish that are being discarded of these 4 landing obligated species, haddock, hake, cod, and saithe. And the black dotted lines that go vertically, that's when we've had a phone call or message to the individual vessel owner, telling them or guiding them on what we've seen and how the landing obligation apply to these species. And then we have later on green dotted lines that are feedback sheets that we start to send once a month to the vessel owner. So that basically also shows what have you been looking at, but also what have we seen of discards and landings and how you compare to your logbook records. The black lines on the x-axis right at the bottom, that shows where we've had a fishing activity, which has been reviewed. And what this basically suggests for this vessel is that in the first haul that we actually review in the beginning of just before March, we saw quite a lot of, especially haddock, 50 haddock being discarded and 37 hake as well. Then they have one more haul before we start a phone call to them, and then have a chat about how is the landing obligation how is the compliance with the landing obligation, what species are covered, and that actually includes haddock and hake. And we do see a decrease for the next couple of trips. We then also take a bit more trips because we've seen that there are some perhaps some risk of non-compliance with this vessel. And again, we do see quite a lot of haddock being discarded, and we have another phone call. And then after that, we see we're not down at 0 at all times. We have fishing activities with the 0 discards, but we're more down to the occasional 1 or 2 discards of mainly haddock and hake. Once a couple of times, it's also cod as well. So that suggests that we have this change in behavior in terms of the catch handling after we start to have a more focused dialogue on how the landing obligation is. And just to show that it's not just that one example, this is a bit difficult to see, but it's a early and a later part of the project where we have the discard numbers and the discard share from our report. And I just want to highlight these hake and haddock. So the top one is the early phase, and we have up to around 26% discard actually of hake, whereas if we compare to the later phase of phase 1, we're down at the 3% discard rate of hake. And we see similar, although not as large changes for haddock and cod. So we do see a change in the amount of discards, both in, of course, kilos, but also the number going out. So what we're doing now is we're starting to practice on more species. This looks a bit overwhelming. We're looking at 22 species, and we're also looking at nephrops for AI training. These are both a focus species, but also species we're looking into in terms of interest, and to maybe, if this goes into the North Sea as well, then we need to be prepared to be able to recognize other species as well, potentially at least. That of course changes the time used. So what we see is for these two plots I show, we have on the top one, the time used in minutes, and then the view speed is the other one. And basically what I want to take from this is that in the beginning we see slow view speed and high audit times. Then the video auditors become more familiar with what they're doing, and we see a decrease. And even though we start to add more species, which we do along the way, we actually stay around the same 50 minutes per video audit of catch handling, and the view speed of a bit more than 1. So it means that they are faster than the actual catch handling on board. Then we're also looking a bit into machine learning, but we are at the level where it's more in terms of seeing if we can sample some images and in the investigation phase, I would say. But there's definitely some potential there, because we do get these snapshots we can take of the different species where we know which species that has been identified at and where it is in the image. We have a little red line showing that as well. So that can be used for training algorithm. The next steps, we are on the brink of phase 2 of the Kattegat. We are expecting 78 additional vessels. Then the pelagic vessel sectors, DBPO in Denmark, they are doing a voluntary uptake of electronic monitoring. And the aim is that all the vessels should have electronic monitoring by the end of this year. We're also in a project with closed areas in the Baltic, and we are actually in the installation phase of 2 industrial vessels currently. And there are some regional projects in the Baltic, North Sea, and Northwestern waters where these will fit into as well. And then finally, we have looking into a more risk-based approach to electronic monitoring. Of course, there are more long-term developments with machine learning and data for stock assessment, and ease of regulations to definitely fill into this as well, because there's some potential for that as well when you start to have these systems on board. If you're more interested in more, then we have on our webpage the evaluation report for phase 1. So I have a link for that here, and there's a Danish and an English version of the report. That's it for my side for this. Thank you very much.
Thank you. So you can stop sharing?
Yeah.
So you can see your face on the screen again. It's the green bar that you were struggling with.
There we go.
Yeah, there we go. Okay, thank you. Really interesting also to see the change in behavior. I'm also I'm a shark nerd. I'm also always happy to see a shark mentioned in any presentation. So good. I'm actually and it's also good to know that they're still hanging on in the Kattegat as well. Interesting. My first question is, if you look at Edwin van Helmond's presentation in the beginning, where they started really working with an AI, do you think that's, feasible in future, because you still work with people actually identifying the data?
Yes, I do really think that there are some potential, and we are thinking that, but perhaps that's also why we're starting to take images of the nephrops, because the reason we're not actually including the nephrops in the focus species is not because we can't identify them, it's just because of the volume. There are so many of them. but if we could start having computer automatization doing the species recognition for those, then we could add that as a species as well. And since I think it's a good training species for starting up machine learning from scratch, because it looks quite different than the rest of the species, except for some hermit crabs we see once in a while.
I think there are some questions about enforcement and how you are going to do that. First the question is, if vessels you contacted about discard hadn't reduced their activity, would you have taken further enforcement action?
Well, there is the option of doing so. Phase one of this project has been voluntary, and there's also been this guiding principles. So instead of taking action and sanctions, then it has been the principle that we should provide guidance and talk to the fishermen. But it still had the option that, of course, if you saw something that was severe or really severe, and then I would say that falling into that category would also, of course, be if you have continuation of non-compliance, then there was the option of doing sanctions. So it wasn't completely ruled out, but it was not necessary, because we did see this change in discards after we started to have this talks with the fishermen. And of course, the people are different, and there's also a difference in how fast this change happens and the extent, but it's the overall pattern is that we see this decrease in discards, and some came from a very low number already before, of course, as well. All of these figures are actually in the evaluation report for as one of the appendixes as well. So you can see the difference between the different vessels actually.
Okay, I'll make sure that when we send out a link to the video recording, we also have these links to the Global Fishing Watch website, your report, that sort of thing, so people can have a quiet look at home. I have another additional question on this, sort of like this change in behavior. Have you is it actually that they're actually moving to other areas as well for fishing, where the sort of the catch is cleaner, or different? Because it's sort of like, I spent a lot of time talking to fishermen, and they would say, well, the bycatch just shows up. So, yeah.
Yeah, there's actually a part of the evaluation was done by the technical university, which was on this question, whether or not you see a change in fishing behavior, and so in terms of the spatial part of the fishing behavior, and it was inconclusive. So I would say that that's definitely something that could be interesting for more research. You have a lot of other factors coming in as well, so it's very difficult to actually discern between, just another one was that this was in the time of COVID, so that actually had an effect on the fisheries as well, just to name one. Yeah. So it was inconclusive. You could not say that there was a change in spatial distribution, and you could not say that it wasn't. So I would say that rather we then focused for our side on this change in discard numbers.
Yeah. Seems like there might be a collaboration between Global Fishing Watch, who have sort of these spatial data, and with Edwin on the AI. So it's nice things might spring from this. So the new 87 cameras, 87 vessels, those will be mandatory?
That's the plan, yes.
Okay. Nice. Did you have any issues with camera tampering? People
nope. We have actually, well, of course, we've had breakdowns. So I haven't put that here, and within this time, we had 4 cases within the time frame of the phase 1 project period, where we had the cameras breaking down, and we actually had a control box breaking down as well. So it was a nuisance, but in terms of time in port to make amends, we were actually looking more into that it was the installation that took the longest, and not these nuisances, which it is, but we have not had anything that seemed to be due to tampering.
I think, Edwin, you also never experienced that sort of thing, right? You also had a lot of broken cameras, but none of them were broken by anybody.
No. Well, it's a challenging environment, of course, so it happens, but it was never caused by on purpose.
So, and I'm seeing another question, and I think that's also more in a broader sense, because I invited specifically you three because these are projects that are already happening. This is not something that we might do in the future, but this is happening at sea right now. And it seems to be that for the Danish and the Dutch project, there was a clear link to the landing obligation and sort of a need for data and a need for the, what would you say would be sort of the biggest hurdles to this sort of things being rolled out in other places in Europe? And I kind of just start with, I'll start with Edwin.
Yeah, it's the scale. I mean, we have quite some experience with electronic monitoring, of course, but it's in Europe as well already for, I would say, more than 10 years. But it's always been on a pilot scale so far. 10, 20, maybe 30 vessels in Scotland, even more. But going from a couple of vessels to over 100, that's a challenge. Dealing with the data stream, the infrastructure around it, the review, IT, maintenance and stuff like that. That's a challenge, I guess. The biggest hurdle.
Thank you. And Kristian?
I definitely agree that there's a big difference in, well, I suppose we'll know, having 100 vessels or having 12 or 21 as we had at one point. But I also think that the whole privacy issue is a big hurdle as well. I actually think that might be even bigger because the other part is more of a technical solution, and it's difficult, and I mean, things are not necessarily that easy, but I think it's more, I wouldn't say straightforward, but something a bit more in that area to say that it's possible to overcome. Whereas we're dealing more with feelings once you get into privacy, and that is a bit more difficult to, how do you tackle that? Of course, you can have certain incentives, but I think there's a more broad topic here, and also in terms of what's actually the right incentive for the right fishing fleets, not just in areas of Europe, but also within each member state.
Yeah, I think also, Edwin, you also stressed that in the Netherlands, it's really a fully documented fishery, so not part of an enforcement program. And that was also a way of getting fishermen more involved in this. And Luca, what do you say? What would be the biggest challenges to getting this rolled out?
Well, for us, again, we are not.
For some reason, you're very soft. Oh, better, probably. Yeah.
Well, I'd say for us, again, things that have been brought up, like confidentiality issues and sharing VMS data, like going transparency is definitely like somehow limiting. For the work we do, we have really good publicly available data. Like again, especially Sentinel-1, Sentinel-2, those are European space missions, so it's a ton of data, free, that we process and work with. IES, it's quite good. And again, in terms of more strict monitoring, like electronic monitoring of actual catches and stuff, like that's somehow like out of our scope for now. We have worked with logbook data and electronic like logbook data. And I think it's going to be really interesting in the future how we can combine those like data. For us have been especially useful for double check like the model, the algorithms, and refine models. But yeah, it's still like for sure something that is not there yet, like on our data and product incorporated fully, like catches and landings and things like that. And that will be, I guess, the ultimate goal, to combine like spatial vessel tracking data with this type of like catching landings data. It would be amazing. But yeah, not quite there yet.
Thank you. If I think you can, everybody can see that I asked Miguel Nuevo to come into the panelist room, although I don't think I can ask him to get his camera off again now. I've lost that.
That's okay. The
okay,
sound is important.
Miguel, maybe you can introduce yourself, and I I saw you as an attendee, and I thought maybe it's interesting because you are from the European Fisheries Control Agency to talk a little bit about this scaling up, going from pilot to larger scale initiatives.
Yeah, thank you, Irene. Very interesting webinar. I enjoyed the presentation very much. My name is Miguel Nuevo. As Irene said, I work for the European Fisheries Control Agency, mainly dedicated to compliance with the landing obligation and in relation to that, to the implementation of REM. As many people know by now, we are working with member states' regional groups to implement some REM pilot projects in new fisheries. But well, we have little experience in the EU. We have only some pilot projects in the past by the UK, Scotland, and only Denmark has some larger experience on REM. So the decision from the member states regional groups was to start small, to start with pilot projects in very manageable sites, so we can gain experience and learn about the implementation of REM in EU waters. It's complicated as everything in the EU because you have to work with many different governments and agree on many issues. But I think we are moving forward at the end of this year, or probably at the latest beginning of next year. We will be able to start the implementation of 3 pilot projects, one in the Baltic, one in the North Sea, and one in Northwestern waters. And from there, we will see how this works and where we go. Regarding the larger implementation of REM, the idea is that we can expand this, but we are also pending the final version of the new control regulation that could, include some provisions for mandatory implementation of REM, and that we could also use for enlarging the scope of these pilot projects.
Thanks. you. Thank you very much for giving that clarification and that background. We've come to, it's actually exactly 12, so thanks for the speakers to sticking to their time and for all your good questions from the audience. As I said, we will make these presentations available online, and we will also send the relevant links to everybody who attended. So thank you very much, and yeah, let's keep in touch and work on these beautiful projects together.
Thank you, bye.
Thank you
very much.